Third time's the charm. Goodness gracious. This is topic 5, unit 5, topic 2. We're going to talk about oxidation reduction agents, how to identify them, how to split these up into half reactions. Let's jump right into it again and see if this time we get it correct. Okay, so on this, I have a balanced reaction. I've got magnesium by itself, that's a 0. I've got hydrogen by itself, that's a 0. I have hydrogen as a rule is a +1 on the left. It has a halogen, which is a -1. Same thing for the chlorines on the right, meaning that if we sum up all those chlorines, that I would have a +2 for the magnesium. So the magnesium is going from a 0 to a +2. That means it is oxidized. That means that the magnesium by itself is going to be the reducing agent. Then I see that hydrogen goes from a +1 on the left to a 0 on the right. That means it's getting closer to the negative. That means it's a reduction. However, in this case, the oxidizing agent is everything in the material. It's all the HCl. It's not just the H. That is just the material that went through reduction, but the entire substance is what is the agent. All right. Seaborgium on number 2 has a charge of 0 to start. On the right, it has a charge of +3. The oxygens have a -2 throughout because we have a rule to establish that. The hydrogens have a +1 throughout, so they didn't change. It's this nitrogen that goes from a +5 after I do the calculations over here that it's going to have a +2. So the nitrogen goes from a +5 to a +2. That is getting closer to the negative. That is reduction. And then the seaborgium goes from a 0 to a +3. That is getting more positive. That is oxidation. But again, the elements by themselves, this is the reducing agent. But if it's a substance, an entire all of it must be part of the oxidizing agent. Okay. Moving down to the half reactions. So I've got to split this up. You can clearly see the sulfur is going to be one material and the nitrates are going to be the other material, the nitrogen oxides. So I'm going to write these as 2 half reactions. Then I'll try and identify which is which. So the sulfur goes from a -2 to a 0, meaning for this to balance out, I'm going to have to put electrons. Well, I can either put the electrons over here or the electrons over here. If I add the electrons to the left, I would have more negative. But if I add the electrons to the right, what you'll see is that the total charge balances out, -2, -2. So since I'm losing electrons, I have identified this now as my half reaction that is oxidizing. On the second half reaction, I've got nitrogen monoxide, NO. And then on the right, I've got NO3-. So my charge of the oxygen did not change. What changed is my nitrogen went from a +2 to now a +5. It's becoming more positive. That means that it has lost electrons also. Well, that doesn't make sense. So I've got something else wrong here. Let me see if I had it right then. -3 on this side and a 0 on that side. I think that's what I meant to do. All right, so now I have a +5 on the left, and I have a +2 on the right. That means it's gaining electrons, and that's why I have it on the left. This is a reduction. Okay. That's correct. Okay, so now let's jump down here to the bottom and let's notice the oxygens, they're not changing their charge, neither are the hydrogens. So what's changing are these nitrogens. They're both converting into the same nitrogen, which has a charge of 0. So I have one of these half reactions, NH3, its charge is going to be its charge is going to be -3, and it's going to turn into the nitrogen. And what this means is it's losing electrons. That's oxidation. Then the other nitrogen, NO2, it's going to have a charge of +4, but it is going to go to nitrogen 0. So that means it's going to need to gain electrons. This is reduction. All right. This is everything that I wish to share with you about today's lesson and the practice for the homework. Thank you so much for paying attention. Bye-bye.